So now we have operations with complex numbers, and as I said in the first video that really the complex numbers are the overall number system, those that can be, written in the form of a plus or minus bi, where I is an imaginary number known as the square root of -1. So before I solve and compute these different problems, I will briefly tell the values of I and exactly how you can do this in a faster method. So if you know that I is the square root of -1, I square is -1. Similarly, if I square is -1, then I to the power of 4 should be 1. Because think about it, I square to the power of 2 is really -1 times -1, which is 1. There may be problems when you have to compute something like I to the power of 60. But it's easy because you know that 60 is a multiple of 4. Therefore, I to the power of 60 should also be 1. So that's just the basics of complex numbers. So here in the first problem, I have 1 plus 3i times by 5 plus 8i. And so once you compute this, you see that 1 times 5 is 5, as we just used the distributive property. And then 1 times 8i gives us 8i. 3i times 5 gives us 15i. And then 3i times 8i gives us 24i squared. So again, what's I squared equal to? -1. Therefore, when we simplify this further, we get 5 plus 23i plus 24 times by -1, which is essentially -24. So we do minus 24. And then solving this further, we get -19 plus 23i. So this is you could say the simplified version because we have brought this in the form of a plus or minus bi. So this is what we have now. Now moving on to the second problem, as you can see there, we have 4 plus 2i cubed times by 5 plus 8i. So again, using the distributive property, we get 4 times 5 is 20, 4 times 8i is 32i, 2i cubed times 5 is 10i cubed, and then 2i cubed times 8i is 16i to the power of 4. So again, think about it. Now, we look at I cubed. Now we know that I squared is -1. And really we have -1 times another I, which is really -I. So when we simplify this further, we get really -1 times 10 times I. So we're left with -10I. Similarly, we know that I squared is -1. Therefore, I to the power of 4 is 1. Therefore, 16i to the power of 4 is really just 16. Solving this further and subtracting 10i from 32i, we have 22i, and 20 plus 16 we get 36. So our final answer would be 36 plus 22i. And now comes division. And so with division, again, I will prove that multiplication and division are really just opposites of each other. So here we got -19 plus 23i as our answer. If we divide this by 5 plus 8i, we should expect to get the answer 1 plus 3i. But how do we really divide values that have imaginary numbers? We need to find the conjugate. And really what the conjugate states is that if there's 5 plus 8i here, we are going to multiply this value by a certain fraction which has a minus here. So really we're multiplying this by 5 minus 8i divided by 5 minus 8i, because really 5 minus 8i divided by 5 minus 8i is 1. So really, we're not changing or altering any value. We have the same value. But why are we doing this? So we can eliminate the imaginary value from the denominator. As we all know, a plus b times a minus b gives us a squared minus b squared. So if we have 5 plus 8i times 5 minus 8i, that gives us a plus b times a minus b. So that's basically 25 minus 64i squared. I squared is -1. Therefore, this is really just 25 plus 64, which is 89, as you can see on the bottom. And solving out this is using just distributive property and adding and subtracting everything, we get 89 plus 267i all over 89. And so really, of course, you can split this into two fractions with a common denominator of 89. So you really have 89 over 89 plus 267i over 89, which is essentially 1 plus 3i. And that's what we had earlier here. Thank you for watching.